Hello everyone, welcome back to Joe Microsphere. If you're new here, please don't forget to subscribe, share, and like. So today's video is very simple. We have already do a video on how to perform line use land cover and then change detection. So if you're new here, you can check my page and then find all those videos before this. So before you can perform accuracy assessments, you need to have your classified land cover classes. So here I have my classified land cover classes for 2020. I have 2025 here too, and then I have 2010, and then I also have 2000 here. So these are the classes that I have. So if I want to perform accuracy assessment for a full project, I have to perform the accuracy assessment for each of the classes here. So we don't perform it for only one, or we don't perform it for the change detection. We perform it for the classes, all all the years that you have the classified image for. So this one, we are going to perform our accuracy assessment for land use land cover 2020. So it's the same process that cuts across all the classes. So please take your time and then follow the tutorials. So the first thing that we need to do is we need to create our accuracy assessment point. So here we are going to create a point here around the map, and then we can visualize the point in Google Earth Pro. So first of all, let's create our accuracy assessment. How do we create accuracy assessment? We go to image or analysis. You go to view or analysis. Then you click on geoprocessing tool. So here we have our geoprocessing tool here. Then you search for create accuracy assessment point. So create accuracy assessment point. So this is create accuracy assessment. This is our create accuracy assessment point under spatial analysis tool. So this one we are not using the image analysis tool. So please do well to check. So here we use the spatial analysis tool. So you click on it, and then this interface will open for you. So we have input raster, we have dimension field, we have output raster. So here input raster will be what our line use land cover 2020, because this is what we are creating the accuracy assessment point for. So you click on it, and then this is the output. So please save it at where you can retrieve it. So here we have our output accuracy assessment point, and then we have target field. So the target field, we have the classifier there, so keep it as classified, you don't change anything. Then the number of random point, simply means the number of points that you are going to display on the map, and then later visualize it in Google Earth Pro or anywhere that you can visualize the point. So here we have our number of random point here, 500. So due to the tutorial, I'll change it to 50. But if you are doing a full project, you can keep it at 500, or you can change it to 200, 150. They are all accepted. So here we have our sampling strategy here. So the sampling strategy is simply means how we are going to sample the point, or how the point are going to be displayed. So we have random point, we have equalized stratify random, we have stratify random. So let's keep the stratify random as a default, and then we click on run. So after clicking on run, you can close this one here, and then this is the point that you are going to see. So these are the point that we created. So this is our accuracy assessment point here. So we have our points here. So these are the point that we are going to export to Google Earth Pro, and then confirm if the classifier we did correspond to the ground truth. So we are going to compare the classified and then the ground truth. So what we need to do is we need to go to the same geoprocessing tool, and then search for layer to KML. Why layer to KML? Because Google Earth Pro accepts KML format. Though it accepts other formats, but the KML format is very simple for you to visualize. So here we are going to save our point in the KML form, and then upload it to Google Earth Pro, and then visualize the point over there. So to save it, or to save your point to KML, you search for layer to KML. So layer to KML. So here we have our layer to KML here under the conversion tool. So you click on it, and then input layer here. You input your accuracy assessment point, which you created here. So this is my accuracy assessment point, and then the output is where you are going to save it. So this one, if I leave it as a default, it's going to save at here Gamma project, and then you will see the final name over here. So this is the name of how the my point is going to save. So after that, you leave everything as a default, and then you click on run here. So after running, you move straight to your Google Earth Pro. So this is my Google Earth Pro here. So here you can see I have my points here. So this is the point that I created. So to upload your point to Google Earth Pro, so you simply go to files. So let me close this one. You go to files here, and then you go to open. So you click on open, and then it will take you to your piece where you have saved it. So let's say this is my ArcGIS Pro. You just click on it, then you click on open. So after you click on open, it's going to take you to this place where you can visualize the point. And then to change the size of the point or the color of the point is very simple. You right click here. So you just right click here, and then you go to properties. So we have properties here, and then you go to styles and color. So here you can change the label, you can change the icon type. So here, if you want to make the icon very big, you change this one from 3 to, let's say, 5. So you can see the icon is increasing here, and then you have the color here. So the color too, if you want to increase it, you can increase it here. All right, so, or if you want to change the color, just click on the color palette here, and then you choose different color which you want to represent it with, which you can see. So you can pick any color of your choice, and then you will represent it here. So to verify your point, here is the point that we created, right? So here we have our point here. Okay, so these are my points here. So all these points fall within where our water body. So we are going to confirm this one to the classify image as ArcGIS Pro. If the point that fall within the waterlog area is the same point that fall within the waterlog area in our classified map. So let's visualize these 4 points. So we have these 4 points here. So let's visualize them. So we are going to compare it. So these are the points. So let me zoom in. All right, so these are the 4 points that we visualize it in Google Earth Pro. So here we can confirm that all those 4 points fall within the water body. So that means these 4 points are correctly classified. So you can check the other point till you are satisfied with your accuracy point. So these were the 4 points. So let me go back so that you can visualize it again. So these are the 4 points that we created here. Okay, and then here you can see we have all those 4 points which have been classified as water body, which correspond to the ground truth. All right, so here, after confirming all your points, you right click on your accuracy assessment point here, and then you go to your attribute table. So inside your attribute table here, we have our classified and we have our ground truth. So the number that you see here, so let me make it ascending so that we can visualize it very well. So here, the number that you see here is the number that was given to the classes. So how do you see it? So you go back to your content, you right click on your classified map, then you go to attribute table. So inside your attribute table, you are going to see class value. So the class value is the value that was given to each of the class. So here we have class value of 10 representing water body, 20 representing built-up, 30 representing bare area, 40 representing wetland, and then 41 representing what? Vegetation. So these are our classes. And then the name here, so here the name will not appear, only the class value will appear. So you have to know the class value that you assign to each of the classes. So here, after knowing them, we classify. So here is my ground truth, and here's my classifier, and here is my ground truth. So you correspond the ground truth with your classified map. So here is 10. You double click here, and then you change here to 10. So if it was misclassified, so let's say 10 is water body, and then it's misclassified with, let's say, vegetation or agricultural land, which is, let's say, 42. So here, here is not supposed to be 10, it's supposed to be 42. That means the classifier was water body, but the ground truth was misclassified to, let's say, agricultural land. So you put 42 here. So that means it was misclassified. So here, after getting your ground truth and then your classified, so you do it for all the classes, as you can see here. So after getting it, you go back to your view, you go back to your geoprocessing tool, and then you search for confusion matrix. All right, so you search for compute confusion matrix here. So here we are going to compute our confusion matrix. So here is our confusion matrix. So input accuracy assessment point, the point that we have correctly classified based on our classified and then our ground truth here. So you go to your input. So your input accuracy assessment point will be your corrected land use land cover 2020. So this one, and then we have your confusion matrix. So here is just the output where you want to save it. So you can leave it as a default, or if you have a working folder. So I normally encourage students to, or a practitioner to have a working folder. So anything that you do will go to one folder. So when you want to retrieve it back, it will not be very difficult for you to retrieve it. So you save it in your working folder, and then you click on run here. All right, so our compute confusion matrix has been done. So let's go and then visualize it. So I can close this one for now. All right, so this is our 20 land use land cover confusion matrix. So you're going to right click on it and then open the attribute table to see our accuracy. All right, so here we have our producer accuracy, we have our Kappa, and then we have our user accuracy. So here we have the C classes. So you see we have 10 here, 20 here, 30 here, 40 here. So if you want to export the table to make your analysis, you change the class values to the actual name so that it will be very simple for readers to identify the classes. And then we have our producer accuracy here, and then we have our overall accuracy. What does it mean when we say overall accuracy, or when we say producer accuracy? So when we say overall accuracy is simply measure the number of corrected pixel over the total number of reference pixels. So if you have a number of corrected pixel and then you have the number of corrected pixel, so you divide it by 100 and then you get your overall accuracy. So and then also when we talk about producer accuracy, producer accuracy simply means of all the location that were truly belong to, let's say, a class, how many did the classification correctly identified. Okay, so let's say all these places were water body, where how many or how well were the classified or the algorithm were able to classify that place as water body. Okay, and then we have our user accuracy. So the user accuracy is correctly classify sample in a class divided by the total sample classified as a class times 100. Okay, so when a map labels something as a forest, how often is the place actually a forest, right? So when let's say my classification correct or perform accuracy that this place is a water body, how often is this accuracy consistent? Are you okay? And then we have our Kappa coefficient, right? So the Kappa is the overall accuracy. So here we have, and then also we have error of omission and error of commission, which is also another side of what we are doing. So for the Kappa coefficient, we have the overall here. So here, if I go here, you can see we have our Kappa here. So that is the 86. So the 0.86 means our classification is 86% correct, which is acceptable, and then which is you can use it in your analysis or anything that you are doing, right? So if you want to get a table, you can just click here and then you select the table and then you copy it here and then you paste it in Excel and then you edit it. So this is a very simple way to perform accuracy assessment in ArcGIS Pro. Thank you once again for your attention, and please, if you have any comments, concern or contribution, please don't forget to leave it on the comment section. And then also, if you want to reach out to me, you can check my page. My email is there where you can email me and your concern. You can email me your concern and then I'll get back to you very soon. Thank you very much for your attention. Please don't forget to subscribe, share and like. Thank you.